click this link, right? Okay, and I will give you a code, okay, for you to join. Okay, so the code is 67742. 67742. Okay, so that's the code. 67742. So maybe for those who just joined the class, okay, so you can click the link here. Alright, and the code is this. Okay, so all of you already here. Okay, thank you. So waiting for others to join. There should be 35. If you have any problem, okay, to enter the code, okay, and enter the class, can you just please tell me in the chat? Okay, 4 more. Okay, I forward the link again. Maybe some of you just join. Okay, 1 more. So, monitor, can you please check the list, okay, that I show in the screen who is still not joined the last point? 1 more person. Who is it? Or maybe the assistant also can help the monitor to check. Because here already enough 35, okay, but in the class only 34. Oh, so Ye, Kaye, situation. The children. All right. So all already. You mean you have 2 names here? I will remove 1. Okay. So the monitor, can you detect 1 more person who still not joined the class? Jia Yi, Xiying, Erin, Ethan. Who Jia Yu? Jia Yu? Jia Yu is here, right? Wait, I check the name. Yeah, Jia Yu is here. So can anyone text her, say, please join the class point, or maybe she has a problem. Maybe you can tell teacher. Okay, never mind. I will text her. Okay. So we continue. Join already. Okay. All right. So I think we stop until here, right? Is it? Yes. Okay. So explain how the ultrasonic wave, right, are used, okay, by the bat to detect the distance of the obstacle. Okay. So for this one, actually, I already discussed or not. I think I did, right? Yeah. So this one also already done, I think. Wait for a moment. Okay. I think starting from here, if I'm not mistaken. Okay, so please answer this question for number 3. Okay. Wait. Okay, please try to answer this question. So it says here the diagram shows the wavefronts of a plane wave incident on the plane reflector. So which statement is correct about the reflected and also the incident wave? Teacher, this one already discussed. Oh, okay, okay. Sorry. This one? Teacher, I think we also finished already finished discuss for the reflection, is it? Oh, okay. So good. We can enter the new topic today. All right. So we move on to refraction of wave, right? Okay, refraction of wave. Hmm. Okay, so refraction of wave. All right. So what is a refraction? So actually, for refraction, what you should learn in refraction of water wave. Okay, refraction of light, and also another one is the refraction of sound. Okay, so there are three types of refraction. Okay, it involves the refraction, so it's water wave. Okay, and also another one is the light, and other one is the sound wave. Okay. So diagram below shows seawater wave, okay, traveling towards a shore. So observe the wave and compare their shape when they are away from the shore and when they approach the shore. Okay, so you can see it follow the shape of the shore, right? So why this happened? This is happened because of the different of depth. Okay, so you can see when we approach the beach, right, the depth become decreasing. Okay, so the depth of water decreasing, so that's why, all right, the wave, okay, the you can see the water wave, it follow the shape of the beach here. Okay. So the refraction causes wave front to parallel the shape of the coastline, okay, as they approach the shore. Okay. All right. So what happened to the wave as they propagate to different depth of water? So this is the deep area. Okay, deep area. Okay, this one, they say you put a glass slab here, so this one should become the shallow area, and again this one should be the deep area. So the first one, we compare the wavelength, right? So you can see the wavelength for lambda 1 at deep area, okay, is higher than the wavelength for the shallow area, okay, lambda 2. Okay, so this means at the deep area, the wavelength is longer than the shallow area. Okay, then after that, when it back to the deep area, the wavelength become increase again. Okay, so and then after that, we compare the velocity. Okay, for velocity, okay, V is actually equals to F lambda. Okay, this is the formula, right? The speed is equals to F lambda. So when the lambda is increased, the wavelength is increased, okay, the speed also will be increased. So means at the deep area, okay, at the deep area, okay, the speed of the wave is increased. Okay, but at the shallow area, okay, the speed of the wavelength will be decreased. Okay, it depends on the wavelength. All right, so here it said, all right, this one I already explained. All right, so the next one you have to compare the frequency. Okay, compare the frequency water wave in deep area and shallow area and explain your answer. Okay, for the refraction, the frequency is same. Okay, the frequency is same. Okay, like before we learn in the reflection of wave, right? So for the reflection, the speed, all right, the frequency and the wavelength, okay, is same before and after the wave being reflect. Okay, that is for reflection. Okay, but the direction of the propagation of the wavelength is changed. Okay, that is for reflection. Okay, but for the refraction, okay, for the refraction, only the frequency is same. Okay, means after it being reflect, before it being reflect, the frequency is same. Alright, and the wavelength, okay, when the wavelength is depend on the deep of the area. Okay, so here it said compare the wavelength, so we already compare. Okay, at the deep area, okay, the wavelength is longer than the shallow area. Okay, and how about the speed? So the speed, we use the formula V is equals to F lambda. So since the wavelength for the deep area is larger, is higher, so means the speed also should be higher. So the speed for the deep area, okay, is higher than the speed of the shallow area. So here it asks you to relate. Okay, so relate means you can use the directly proportional or inversely proportional, right? So we can say here relate the depth of water to the speed of the water wave. Alright, so the higher the depth of the water, the higher the speed of the water wave, or you can say directly proportional. Okay, directly proportional. Alright, and then another one, when you relate the depth of the water to the wavelength of the water. So just now we see the deeper the water, okay, the higher the wavelength, or we can say also directly proportional. Okay, and then the next one, the relate the speed of the water wave to the wavelength. So this one we just use the formula V is equals to F lambda. Okay, V is equals to F lambda. So when the speed is increased, the wavelength also will be increased. So this one also is directly proportional. Okay, so actually what is the refraction of wave? What does it mean by refraction of wave? So refraction of wave is the change in direction of propagation of wave caused by the change in velocity of wave when the wave propagate from one medium to another medium. Okay, so means the refraction of wave is the change in direction of propagation. Okay, when they enter the two different medium. Okay, and when they enter the two different medium, of course there will be change in velocity. So let's see the first one. Okay, so for this one, this is for the water. Okay, so the speed of the water wave is influenced by the depth of the water. Alright, so this causes the refraction to occur. Okay, because of the difference of the depth of the water. Okay, so this causes the water refraction, the refraction of wave to occur at the water wave. Alright, because of the difference of depth. Okay, how about light? Okay, so what influence, okay, the light reflection? So the light reflection influenced by the density. Okay, the density influence the light to be reflect. Okay, and this one also for the speed of sound, or for the sound, the refraction of sound is influenced by the density. Okay, so means for the light and for the sound, refraction occur because of the difference of density. But for the water wave, okay, it occur because of the different of the depth of the water. Okay, so let's say for the light wave, right? I think you already learned this one. So let's say this is air and let's say this is the glass. Okay, so the light come from the glass. Okay, so can you tell me whether it's refracted away or refracted towards the light? Toward the normal line. Okay, so glass and air. Which one? Whether it's refracted away or refracted towards the incidence, the refraction incidence here. So which one? Which direction will it go? Whether it's refracted away or refracted towards the normal. Towards the normal. Towards, alright, okay. So with between glass and air, which one is more dense? Which one is denser? Glass or air? Glass. Okay, so means this is denser and this is less dense, right? So when the light enter from the denser to the less dense medium, the light ray will refracted away from the normal. Okay, so the answer should be refracted away. Okay, but if the light, let's say this is the normal line, okay, and this is air and this is the glass. So this one, okay, let's say the light come from the air here. So this is the incident ray, okay. Alright, so air is less dense, okay, and glass is denser than air. So for this one, it will refracted towards the normal line. Okay, so it will become closer to the normal line. Okay, so this dotted line is actually the normal line. Okay, so the normal line have to be 90 degrees with the surface. Okay, so this is actually you need to know. Okay, as you can see here, okay, in the diagram here, right? So the light, this is the normal line, right? Okay, so you can see here the water. So water, of course, is much denser than the air. Okay, so you can see it refracted away from the normal. All right, so that's why you see the pencil is like bend. Okay, it bend in the water. Okay, so this one you need to remember. So this is refracted towards. Okay, so never mind, later we will learn in chapter light chapter, we learn about this one. Okay, but this one also you need to remember because later you need to describe for the sound, refraction of sound. Okay. Alright, so the next one you have to write an equation for refraction of wave. Okay, so this is the formula, okay, for the V is equals to F1 lambda 1. Okay, so this one is actually describe the deep region here. Okay, V1 is equals to F1 lambda 1. Okay, and V2 is equals to F2 lambda 2. This one is describe the shallow region. Okay. Okay, then another part, you know that F1 is equals to V1 lambda 1 and F2 is equals to V2 lambda 2. Okay, and you know for the refraction, right, the frequency is same. Right, F1 and F2 is actually same value. Okay, so that's mean we can just equate, right, V1 lambda 1 equals to V2 lambda 2 since both of the frequency have the same value, because for the refraction the frequency is constant before and after the refraction. Okay, so we just can equate the formula here. So you will get this formula. So this formula is only used for the refraction since in the refraction the frequency is same. Okay, don't use this formula for reflection because reflection all change and all is same except the direction of propagation and also the velocity. Okay, so let's see the angle of incident, the characteristic. Okay, so water wave passes from deep to shallow water. So what happened to the angle of incident and angle of refraction? Okay, so I will describe about this one. Okay, I will draw here. So this is the normal line. No. Okay. They say this is the shape. This is water wave. Okay. All right. So first, all right, you have to draw. Okay. So how you can say here the incident angle. Okay. The incident angle is bigger than the refracted angle. Right. So this is deep area, right? This is deep area and this is the shallow. Okay. So the first one, what you have to do, you have to draw the draw the direction of the propagation first. Okay, so this is direction of the propagation for the wave. Okay, you move from the left to the right. Okay, so and then you draw the normal line here. Can you see it clearly? You want me to draw it bigger? Okay, right. So here from the deep to shallow, so means it's enter from the less dense to denser, right? Okay, deep area less dense, shallow area is dense. So for this one, it will refracted away or refracted towards normal. Anyone want to try whether it's refracted away or refracted towards? Less dense to dense. Sure? Less dense to dense. Just now like air go to glass. Refracted towards, right? So the normal line, when you draw the direction, it should be closer to the, so let's say this is a normal line. So the line should be closer to the normal line. Okay. So this is the refracted. Okay. All right. So you can see here, okay, the angle. So the angle becomes smaller, right? Okay. So this is I, the incident angle. This is the refracted angle. So the the I is bigger than R. Okay, because it moves towards the normal line, means the angle will become smaller. Okay, so I is bigger than R. Okay, and then another one, this one, let's say I draw another normal line here. The normal line should be 90 degrees with the surface, okay, surface of the plane here. Okay, so for this one, it's come from the shallow to deep. So now dense to the less dense. So this one should be refracted away, right? So refracted away from the normal. So when it refracted away from the normal, it should be like this. Okay, so it will be refracted away from the normal. So from here is I is bigger than R. I is smaller than R because it refracted away. So means refracted away, the angle must be increasing. Okay, so how about the speed? Okay, so for the speed, all right, it will decrease. Okay, but for the wavelength also will be decreased. Okay, because the speed is actually, we have to see the wavelength. Since the wavelength is decreasing, the speed also will decrease and the frequency will be constant, right, or unchanged, right? But for the when the water travel from the shallow to deep area, okay, the speed will increase because of the wavelength is increased, but the frequency will remain constant, okay, unchanged. Okay, so this is actually the drawing, okay, the drawing for the deep air water and also the shallow water. Okay, so you can see there is a change of the direction of propagation. So later you have to draw. Okay, so here it says the refracted towards the normal. Okay, so this is actually the direction of the propagation. Okay, this is the 90 degrees. This is the normal line. Okay, so you can say it says move towards the normal. So this is the line. So it moved towards the normal, right? And for this one, okay, this is the direction of the propagation. This is 90 degrees. You can see it move away from the normal. Okay, this one it moved towards the normal. This one it moved away from the normal. All right. Okay, so how you want to draw, okay, for the wavelength. Okay, so the first one you have to draw a line. Okay, so this is the line to represent the direction of propagation. Just now like I did, I draw the direction of the propagation there and I mark it with an arrow. Okay, and then after that we draw the normal line. So remember the normal line should be 90 degrees like this. Okay, should be 90 degrees from the surface. Okay, from this surface. So you have to be 90 degrees. Okay, and then the next one, okay, since this deep area to shallow area, so you know you have to move towards the normal line. So you draw the line that closer to the normal line here. Okay, so you draw the line closer to the normal line. If refracted away mean it will move this way. If refracted towards mean it move here. Must be closer to the normal line. Alright. And then after that, okay, now it will enter the deep area, right? So again, you draw the normal line, okay, at the surface of the plane here, okay, and it must be 90 degrees, okay. So here you can see it enter from shallow to deep area, so it will refracted away, right? So you draw the line that refracted away from the normal. So you draw the line refracted away from the normal. And then after that, okay, you just draw the wavelength, okay, but the wavelength should be 90 degrees with the direction of propagation. Okay, so remember just now you draw the line here, right? This is the direction of propagation. So when you draw the line here, the straight line here, it should be 90 degrees with the direction of the propagation. Okay, right? And also here same. Okay, so this is your direction of propagation, right? Okay, so this is the direction of the propagation. Okay, so you have to draw the line here, okay, the straight line here, okay, 90 degrees with the direction of propagation. Okay, this is your direction of propagation, right? Just now that you draw refracted away or towards normal. So this is direction of propagation. So your line when you draw, measure is 90 degrees. Okay. Alright, so same also as this one, okay. So for this one also you must draw the line. This is direction of propagation. We draw just now. Okay, and the line, the wavelength should be 90 degrees with the direction of the propagation we just draw just now. Okay, so that's how you draw the wavelength, okay, when it enters the medium. Okay, so you can see the wavelength here, right? The deep area, okay, the wavelength is higher than the shallow area. Okay, this is the example if you want to do that. If we will do the experiment, this one, okay, when the school open, okay, for the ripple tank, right? Okay, so let's see the video. Refraction of wave in the ripple tank. Okay, so you can see here, right, this is actually the shallow region, right? This is the deep region. Okay, you put the perspex, okay, the perspex block here. So this one will become the shallow region. So this will become the deep area. So the wavelength you can see is much bigger than the shallow area here. Okay, all right. So this one is just like we see just now. Okay, this one is the deep area, and this one is the shallow area. Okay, so it says here not partially reflected wave. Okay, so you can see there is a line here, right? So actually the part of the wave also will be reflected, okay, by the plane here. Okay, but the majority that we can see here, right, is a refraction. Okay, this is the deep area, the wavelength is much bigger, and this one the wavelength is much shorter. So here means deep area, this one is shallow area. Okay, so they change the shape here. So again, you can see this one is a shorter part. So shorter wavelength means shallow here. This one is deep. Okay, so this one from shallow to deep water. Just now we see from deep water to shallow, right? So now from the shallow part to the deep water. Okay, so you can see this is the shallow one. This is the deeper one. Okay, you can see the wavelength here, right? The wavelength is increasing. Okay, because the depth of the water is increasing. Okay, the wavelength become bigger. Right, I will just fast forward. Okay, this one is total internal later. Okay. All right. Okay, can you wait for a moment? Okay. Right, so I want you to draw. Okay, I want you to draw for this one. You can use your mouse to draw. Okay, some already answered. So let's see who's it. Okay, very good, Ethan, Yili. So make sure there is a difference of wavelength there, because of course there will be difference of the depth of water. Okay, 16 more. Okay, 11. Tonzon, Yvonne, Isaac, Caroline, Mickey, Renjeng, Rachel, Yumin. Oh, Tonzon, which one are you? You got 3 names here. Isaac, Yumin. Tongzuen, which one are you? Later I will remove the name. You mean Je, are you okay? Okay, Tongzuen already. You mean? Wait, teacher, I cannot control my mouse. Yeah, I know it's hard to draw by using mouse. It's okay as long I know which part is the wavelength is longer, okay, and which one is more shorter. It's okay. Okay, we wait for Yumin, then I will close. Everyone has to give a response because I will use this one as your PBD, okay, as a proof. Make sure you draw I think the direction of propagation already been drawn for you. Okay, thank you. Okay, so this is your drawing. Put inside the slide first. Okay. All right, so how you want to draw for this part? So of course, the first one you have to draw the direction of the propagation. So for this one, it's only the straight line. Okay, only a straight line like that. Okay, so at the shallow part, you have to draw the wave. Oh my god. Okay, let me draw first. Okay, so at the shallow part, the wavelength should become shorter. Okay, than the deep area. Right? Okay, so at the deep area, okay, Okay. Alright. So that's the answer. Okay. At the shallow, the shallow part, the wavelength will become shorter. Okay. So let's see your answer here. Okay. So that's the direction of the propagation. Alright. Very good. Okay. Alright. Okay. Right. Jaya, this is wrong. Yang. Because you don't need to draw the normal line, because the normal line is actually same as the direction of the propagation, right? It should be 90 degrees, so it's just same, so you cannot draw the angle there. Okay, very good, very good. No need to draw because the normal line is here, right? It's same as the direction of the propagation. This is the normal line, and also at the same time the direction of the propagation also at the normal line, so the angle is 0. Okay, so for this one, Qingyang, you should draw closer to each other, right? Junhin, wrong. Okay, Chushan, correct. Okay. Can you understand why I said that you don't need to draw the angle here? Because this is the direction of the propagation, right? And the same time, this is also the normal line. So the angle of incident is 0. So you don't need to draw the angle of refraction. And another thing, the plane is a straight line plane like this. So you don't need to draw the angle of refraction because the angle is 0. Okay, very good. Very good, very good. Okay, Jayu. Okay, so this one. I already marked, right? Okay, this one wrong. Yeah, correct, 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 correct. Okay, wrong. Why? They have duplicate. Lagi. Wait. Maybe I click twice, so it become like that. Okay, right. So for this one you have to draw the normal line, right? Because you can see the normal line is supposed to be 90 degrees with the surface. Okay. So it should be 90 degrees, so it should be like this. So means there is an angle here. Okay, just now it's a straight line like that, right? So when this is a straight line like that, this is the direction of propagation, right? So if you draw the normal line also should be here. So means there is no angle. So you don't need to draw the whether it's reflected away or reflected towards. Okay, so you can try to draw. Draw the direction of the propagation. Just one that I teach you before. Remember, deep to shallow means from less dense to dense, reflected away or towards normal. Okay, so I see someone already submit. Okay, Chushan. Very good. Okay, still waiting for 23. So next time if you want to join, like maybe you disconnected then you want to join again, make sure you use like maybe you're using your different name, maybe some one using space, some another one no space, so I can know which one I can remove. Okay. Okay, 15, 16. We wait for 19 more. Okay. So waiting for Isaac, Yanzhen, Yuming, and Tonzuen. Okay, Tonzuen. Okay, good. Okay, so this is your answer. Okay, where is the wavelength? Okay, so this one is from deep to shallow, means it will be refracted towards the normal line. Okay, should be like this, right? Alright, it should be refracted towards the normal line. And then for this one, okay, for this one you draw the normal line. Okay, must be 90 degrees from the surface. Okay, so this one also should be, this one is reflected away, right? So reflected away. Okay, so this one you have to draw. Okay, draw the wavelength. Okay, and make sure the wavelength is 90 degrees with the direction of propagation. So it should be something like this. Okay, and must be closer. Okay. Okay, like that. Must be closer. Okay. Alright, and for this one, okay, so this one should be 90 degrees, right? Okay, so it should be like this. This is the direction. Be like this. Yeah, because it should be 90 degrees, right? It should be like this. Okay. Alright, so let's see your answer. Okay, so this one you have to draw the wavelength. Okay, don't just draw the direction of the propagation. Okay, and this one also you should draw. Okay, it should be 90 degrees. Where's your normal line? Okay, so this one should be like this, right? Okay, okay, good, Ziying. Okay, good. Okay, this is wrong. Okay, wait, I mark first. Correct. Oh, no wonder I cannot mark. Okay, so this one is correct. Okay, this one is wrong. Wrong. Correct. Correct. Okay, correct. Yeah, but there's no normal line here, so wrong. Okay, wrong. Okay, this one also. Okay, this one is correct. Make sure you draw the normal line. Okay, very good, Shonki. One. Okay, no, no, no. Okay, this one no wavelength. Okay, okay. Wrong. Um, wrong. Correct. Okay, correct. Wrong. Um, no, no. Correct. Okay, wrong. Um, okay, correct. Okay, no, wrong. Okay, correct. Correct. Wrong. Okay. So that's how you draw. Anything you want to ask, teacher? So this is another shape, okay? So I will just show you. This is how to draw it. Okay, right. So you see, should be 90 degrees. Okay, so it should be 90 degrees with the direction of the propagation. So this one, okay, because this is the normal line is on the direction of the propagation, right? So you cannot draw the angle here. So means the angle of incident is 0, right? So means there is no refraction. Means no, not refraction, no angle. So the direction of the propagation will be in the same line, in the straight line here. Okay, then here, starting from here, okay, so the normal line, this is the normal line, should be 90 degrees with the surface here. Okay, so here you can see it's from shallow to deep, means from the less to less dense, so it will refracted away. So you can see the line here is refracted away. Okay, and then you can see the line. Okay, it's like this. Okay, you draw 90 degrees from the direction of the propagation. Okay, so this is for the perspect, okay, for the block that shape like the convex and concave. Okay, so concave you can see here. Oh, sorry, this one is convex. Okay, so convex you can see the wave here. Okay, the wavelength when enter the shallow area, okay, it will become closer. Then after that, when it go to the deep area, it will be converged into one point. Okay, so this is called as a focus point here. Okay, so it will focus into one point. Okay, but this one is a concave, right? It's a concave, so concave it diverge, so it will spread the wavelength. Okay, it will spread the wave like that. Okay, but the shape that will follow the shape of the concave lens. Okay, so for this one is curved like that, so the wavelength also should be curved. Okay, and this one they focus into one point. Okay, so when the wavelength come out from the convex lens, it will focus into one point. Later I will show you a video, right, for the concave and the convex one. Okay, so we try to do the exercise here, right? So this one, remember, you want to calculate for the refraction, we use V1 lambda 1 equals to V2 lambda 2. Oops. Okay. 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 12 more. Okay, Jiying, Joey, Jai, Je dan satu lagi siapa? Siu Vun. Je is it correct I said your name? Je Oh, you have two names, is it? Okay, one more. Okay, so all already submit. Okay, so let's see the answer. Right, plane wave has a wavelength of 2 cm and a velocity of 8 cm as -1 as it move over the surface, okay, of the shallow water. So when the plane move, okay, into the area of greater depth, okay, its velocity become 12 cm per second. And what is the wavelength of the wave in the area of greater depth? Okay, so here means you should decide, okay, you want to put V1 lambda 1 is a deep area or V1 lambda 1 is the shallow area. So for this one, let's say they move from the surface of the shallow water. So shallow water should be V1 in lambda 1. Okay, so I put the formula here, V1 lambda 1. So remember for the calculation problem, okay, for the calculation, you have to show the formula. Okay, so means V is velocity is 8 and wavelength is 2. Okay, and at the deeper area, the velocity become 12. So 12 lambda 2. Okay, so just cross multiply, should be 8 lambda 2 equals to 24. Lambda 2, 24 divided by 8, 3 cm. Okay, so let's check your answer. Okay, very good. Some of you shows 1.33. How you can get 1.33? 0.33. Why? Okay, next time please show the unit. Okay, what's the unit? Okay, so this one is cm, right? We check first. I'm afraid I'm going to miss out. Okay, so correct. Oh, 4. 12 divided by 4 is 3, right? Okay, wrong. Typo, okay. So we move on to the next one. Okay, this one be careful, okay? They only want one wavelength. So this is how many wavelength? Okay, make sure you find one wavelength first, okay? Just don't take 12. Have to calculate how many wavelength is there for 12 cm. So we just the same formula. V1 divided by lambda 1 is equals to V2 divided by lambda 2. Okay, remember that one is only for refraction. Okay, Shonki, Thompson, Yvonne, Qingyang, Caroline, Mickey, Rachel, Joey, Jiying, Qihao, Ethan, Yvonne, Jiayu, Tongzhen. Okay, we wait for 9 more. Is it hard? Teacher, I have 2 names. So you already submit. I also submit. So means only Shuangqi, Qingyang, Ethan, Qihao, and Yvonne, I think. Plus 4 more. Yvonne, Qingyang, Qihao, Ethan. Okay, 2 more. Yvonne, Yvonne, teacher already submit already. So who's one more? So Yvonne also already submit. Tongzuan also already submit, right? Because you have 3 names. Okay, when later I will check. Choose another one. Okay, so here we use the formula V1 lambda 1 equals to V2 lambda 2, right? Okay, so it says calculate the speed of the water wave in Q. So mean we have to find V2 here. Okay, if the speed of the water in P is 80 cm per second. So we already know, okay, at P 80 cm, so V1 is 18. Okay, how about the lambda 1? So lambda 1 is how many lambda here? 1, 2, 3, 4. So there are 4 lambda here. So 4 lambda is equals to 12. 1 lambda is equals to 3. So lambda 1 is 3. Okay, then V2 you need to find. Okay, and the lambda 2 here is 1, 2, 3, 4, 5, 6, 7, 8. So 8 lambda is equals to 12. So lambda is 1.5, right? 1.5. Okay, so you just cross multiply. 18 times 1.5 divided by 3. So you will get 9. Make sure you write the unit. Okay, so let's check your answer. Okay, 36. How you get 36? 12. How you get 12? Tongzuan. 18. How do you get 18? The answer is 9, right? 9, 18, 9, 4. Isaac, how you got 4 cm? Oh, you use 18. No, you have to find one wavelength first. Okay, correct. Wrong, correct, wrong, correct, wrong, correct, wrong, correct, wrong. Okay, can you understand for those who got this question wrong? Can you understand how do I get 9? Are you clear? For those who got this question wrong, let's say example like Chushan, Tongzuan, Viresh. Okay, so if you don't understand, you can tell me. Okay, I will show you again. All right. Okay, so let's move on to the next one. Okay, so diagram shows a water wave move from region P to region Q at different depth. Okay, so which region is the shallow region? So of course the one with the shorter wavelength is the shallow region. So the answer should be Q. Okay, and you have to compare the speed. All right, so means the speed for Q is smaller. Okay, because the wavelength is smaller. and both for the frequency, okay, for the both region is actually same, right? For the refraction, only frequency is constant before and after it being reflect, okay, but for the speed, all right, speed, wavelength, and also the direction of propagation, okay, there will be a changing, okay. Right, so this one diagram shows a star-shaped tank with three regions X, Y, and Z with their respective increasing depth. Okay, a vibrator produces plain water wave in region X and move to region Y and Z. So you have to draw a diagram. So you can see at Z. So Z has a deeper area, okay, compared to Y and also X. So means at Z the wavelength should be longer. Okay, should be further away. Okay, then after that Y, then after that Z. So it will decrease. Okay, so the wavelength will be decreased, right, from Z to X. So you can see here the wavelength become decrease. Alright, the next part is you have to discuss the natural phenomena of refraction of wave. Okay, so the movement of seawater, okay, wavefront from the open sea towards the seashore is shown in the diagram below. Okay, so this is at the cape. Okay, so at this part. Okay, so this is the cape, right? And this is the bay. Okay, this is the bay and this is the cape. Alright, so let's see what happened at the cape first. So at the cape, we can see the wavelength here, okay, become shorter. Okay, the wavelength here become shorter. So this is the shallow water region. Okay, shallow water region. So it has a lower speed. Okay, since it has a smaller wavelength, so the speed is lower here. Okay, but because of the shape here, you can see the shape of the cape here is like the convex. Okay, so it's like a convex. So you can see just now, like the convex, remember this one, the wavelength that we see when it come from the convex. Okay, you can see all the wavelength is focused into one point. Okay, so all the wavelength here focus to one point, while at the concave it diverges, it spread the wavelength. Okay, it spread the wavelength. Alright, so because of that, because of the shape of the cape there, okay, it look like a convex. Okay, it looks like a convex. So all the wavelength will be focused into one point. Okay, so you can see all the energy here. Okay, all the energy here, you see the the yellow arrow here. Okay, all the energy here is focused to one point. Alright, so means at that part, the energy of the wave is very high. Okay, even it has a lower speed, okay, but because of the shape of the cape, it's like a convex, right? It's like a convex, so all the energy will be focused to one point. So means all the energy of the wave will focus to one point, it will produce the high wave there. So the water is not calm. Okay, we produce the high wave, right? So that is for the cape, right? And then we see for the bay. So since the bay is look like the concave, right? The shape is concave like this, right? It's like that. Okay, just concave like that. Okay, and this one is a convex. Okay, convex like this, right? Okay, so this one, because of it looks like a concave lens. Okay, so it looks like a concave shape. So when a concave shape, you know all the wavelength will be spread out. Okay, it will be spread out, it will disperse. So the energy will be spread out like that. So the energy will not focus to one point. So the water will be more calm, okay, at the bay part. Okay, if you compare with the cape. Okay, so that's why mostly at the resort, okay, if you go to the resort, okay, or chalet, they will build the chalet, okay, at the bay, because usually we go swim at the bay part because the water is more calm. All right, so that's the reason. Okay, so actually because of the shape. All right, so here it says why the wave become closer to each other and follow the shape of the shoreline when they are approaching the beach. So this one because it moved from the deep area to the shallow area. Okay, so the speed of the wave will be decreased. So that's why we follow it will refract towards the normal line. Okay, so that's why it will follow the shape of the beach there. Okay, or the seashore there. Okay, so this one that I just discussed just now. Why the water at the cape has high wave? Okay, so remember cape, the shape is like a convex. Okay, it's like this, right? So this is like the cape. Okay, so it's like the convex. So convex they will focus all the wavelength to one point. So all the energy will be focused to one point. So means here at that part, okay, the energy is very high. So that's why they produce the high wave. Okay, so you see converge. So that's why they produce the high amplitude. So means high wave mean they produce the high amplitude. So why the water at the bay is calm? Okay, because it looks like the concave. So all the energy of the water will be spread, okay, to a wider area. Okay, so the water at the bay is calm. Okay, so are you clear about that one? Anything you want to ask? Okay, the next part is say compare the speed of sound wave. Okay, so at the first part before I start to with the refraction of wave, I already told you that we will learn about the refraction of water wave and also refraction of light, and another one refraction of sound, right? Okay, so refraction of light, we will learn that one on chapter 6, okay, the light chapter. And for the refraction of sound and water wave, we learn in chapter 5. Okay, so it says here, why compare the speed of sound wave in warm air with the cold air. Okay, so the speed of sound in warm air is greater. Why? Okay, so you know when the sound, okay, they want to travel, they need a medium. Okay, they need the air molecule to transfer the sound energy. Okay, so when the air is warm means the kinetic energy is higher, right? Okay, so the kinetic energy of the air molecule is higher, okay, at the warm air. So when they move faster, so of course they can transfer the sound energy faster because the movement of the air molecule there is faster, okay, since they has the high kinetic energy. Okay, so this is the reason. Okay, so the speed of sound in warm air is greater. Why? Because the temperature in warm air greater, the air molecule will gain more kinetic energy and they will move faster. So mean they can travel, they can transfer the sound energy faster. Okay, so during the hot day, right? So it said explain why sound cannot be heard over a longer distance on the hot day. Okay, so on the hot day, okay, at the below part of the air layer, okay, so there is a warm air. So warm air, less dense, right? Warm air, less dense, okay. All right, for the cool air, okay, is denser than the warm air. All right, and then you already know, okay, I already told you just now, okay, when the sounds travel from the less dense to dense, or maybe other kind of wave, maybe water wave also, if they travel from the less dense to the dense area, it will refracted, okay, it will refracted away or towards. Teacher, can you move the previous slide, that A part? This one, is it? Before, which one? This one. Is it? Before. This one, is it? Oh, you want to copy down the answer, is it? Never mind. I will save this one as a PDF, okay? Then later you can just copy down. Is it okay? I will save all this on PDF, then later you can copy down. I will send in the group, okay? Alright, so just now. Okay, so less dense to dense. So I see someone said it moved away. I think someone said away or towards. Okay. So this one less dense to dense mean it move away or move towards? Less dense to dense. It move towards, right? So when it move towards the normal line, so you can see it move towards. Okay, it become closer to the normal line. So means the line, means the sound we travel away from the earth. Okay, because it moved from the less dense to dense. So less dense to dense, it moved towards the normal line. So towards the normal line, it will become the sound will travel away from the earth's surface. So that's why you cannot hear, okay, so well during the hot day. Alright. So here this explanation. So the sound will travel faster in warm air. So on the hot day, the layer of the air near the surface to be is warmer. Okay. So the sound travel from hot to cool air. So the speed of sound decrease. Okay, and the sound is refracted towards the normal line because of the difference of the density. Less dense to dense, it will move towards. Then after that, it will move away from the normal line. Okay, so it will refracted away from the earth. Okay, and then what happened during the cool night? So at the cool night, okay, here at the lower part, okay, of the layer of air here, so here will become denser. This one should become less dense. So dense to less dense, it will move away from the normal. So it will move away from the normal. It will move towards the earth. Okay, so that's why we can hear clearly, okay, on the cold day. Okay, so at the night, okay, the ground cools, so the air layer near the ground colder. So the sound travel from cold to hot air, so means from the dense to less dense. So the sound will be refracted away from the normal. Okay, so when refracted away from the normal, it will move towards the normal. So that's why you can hear it clearly. Okay, so this one is because of the density. It seems like the water also. Water is not, water is because of the depth of the water. This one is same as the light. Okay, because of due to the difference of the density. Okay, so I think I will stop there first. Okay, so later I will give you all the slide, right? So we continue. Okay, before I forgot, on Thursday, 1 hour. 1 hour is only for the presentation. So I hope all of you can get ready. Make sure your mic is okay, your PowerPoint is working well, can show the slideshow preview. Okay, I don't want to be like 4S before. Okay, some also I cannot hear the sound, cannot see the PowerPoint clearly. Okay, so make sure you test it first, right? So I see you on Thursday. Okay, so take care everyone. Okay, bye. Bye-bye.